Okay, this is part 2 of the lecture notes. This should be the last the last little bit of chapter 28. We had left off on slide 63 with the class Insecta, which are part of the phylum Arthropoda. Insects always have 3 body segments. You probably know this because we start learning this when we're little kids in school. There's a head, there's a thorax or chest, and then there's an abdomen. Spiders, for example, have like a head and thorax that's kind of fused, called a cephalothorax. But insects have a separate head, thorax, and abdomen. That's 3 body segments. They also have 3 pairs of legs, and sometimes they have wings. So a grasshopper is an example of a typical insect. A grasshopper does undergo metamorphosis like most of the arthropods, but it's incomplete. That means that it has a gradual change in form. It doesn't undergo such a drastic change like butterflies do. Grasshoppers have little air holes in the side of their bodies called spiracles, and air enters through the spiracles and then into trachea. So we humans have 1 trachea. Grasshoppers have a bunch of little trachea, and that's how air enters. These are some different insects, very diverse. This is a mealybug. This is a beetle. This is a leafhopper. We have a head louse, which is obviously blown up, so because they're much smaller than that. We call them lice. This is a wasp. This is a dragonfly. And here's your grasshopper, and you can see these little holes, the little spiracles. That's where air goes in. And then from the spiracle, they enter trachea or little air sacs. So they don't have lungs, but they're getting more complex, compared to the other animals that we've studied. The chelicerates, okay, so it would be phylum Arthropoda and subphylum Chelicerata. And then there are different classes. Like the spiders, scorpions, ticks, and mites are in the class Arachnida, but the horseshoe crabs and the sea spiders are in a different class. Excuse me. The chelicerates all have 2 pairs of appendages that are attached to their cephalothorax. Sorry. Their legs, and then also the first pair of appendages, which are called chelicerae, and that's where the subphylum name comes from, Chelicerata. The chelicerae are used for feeding and also defense. And then they have a second pair of appendages called pedipalps, which help in feeding, and also they're part of their sensory systems as far as touch. So here's a horseshoe crab. This is a scorpion, which is in the subphylum Chelicerata and also the class Arachnida. A black widow spider in class Arachnida. The horseshoe crab is not in the class Arachnida. It's in a different class. But I would expect for you to remember the class Arachnida because we all know that spiders are arachnids, Okay, now, last section is on the echinoderms. Now, this is the only animal group, the only animal phylum that is a deuterostome, except for the vertebrates, which are also deuterostomes. So the echinoderms are really the most closely related invertebrates to humans, except for the invertebrates that are in the phylum Chordata. There's a few examples of those, the sea squirts and the, what's the other one? The tunicates and the lancelets and the tunicates. Okay, so there are 2 examples of invertebrates in the phylum Chordata that are deuterostomes, of course. So the deuterostomes include the phylum Echinodermata, which are all invertebrates, and then also the phylum Chordata, which will be in the next chapter, and that is mostly vertebrates. So let's talk about the phylum Echinodermata. We know they're invertebrates. We know they're deuterostomes, meaning the second opening during development forms into the mouth. The examples would be sea stars, sea urchins, sea cucumbers, sand dollars. As adults, they have radial symmetry, but their larvae are bilateral. They do have a water vascular system. We will dissect a sea star, and this will be a big part of it, is going through the water vascular system, how the water comes in, and then how it fills up the tube feet that they use for moving or locomotion. The water vascular system is also used for feeding. It's also used for gas exchange and for sensory reception. This is a sea star, and you can see the water vascular system. It starts with, there's like a stone. You'll see it on, it doesn't look like a stone here, but there's a little small stone sitting here called a sieve plate or a madreporite. The water goes through there, and then it enters the stone canal. Okay, I'm sorry, I got a phone call and I'm trying to remember. Oh, I was going through the water vascular system. So we're going to learn this in lab, but very quickly I'll just go through it. There's a stone here and water enters it. I know it sounds funny that water enters a stone, but it's porous. So it allows water to come in. Water goes down this canal, which is called a stone canal. And then water enters what's called a ring canal, which is in this area. And then there's a canal that goes down every one of the rays or arms, and it's called a radial canal. And then the water enters the tube feet, which are on the bottom. These are some other echinoderms that you might not be as familiar with. Particularly, you may have never heard of a sea apple, but this is an echinoderm called a sea apple, and these are sea urchins. You've probably seen those before. And then here's the sea star. It doesn't show a picture, but anyway, it just talks about the tube feet and the water vascular system here. And we will learn how sea stars eat whenever we dissect them in lab. So I'm just gonna end here, and then just make sure that you have taken notes and you're ready for a quiz on Monday on the chapter 28 lectures.